All right, let's have a quick look here. So stuff like this. Okay, there's really aren't too many different kinds of questions to talk about here, but one of them would be like this. We're supposed to rewrite this rational function. Remember what the definition of a rational function is. Rational function is anything that can be written as a polynomial divided by a polynomial, right? So we got this rational function, and we want to write it in the form, in this form right here, right? And why would we do that? Because then it relates the graph to the parent function. It looks like this. All right, if we graph f of x equals 1 over x, what did that graph look like? What does an inverse function look like? Because that's what we'd call an inverse function. Yeah, it's just going to be one. It's going to go through the point 1, 1 in quadrant 1, and it's going to have asymptotes, a vertical asymptote on the y-axis and horizontal asymptote on the x-axis, right? And then in quadrant 3, it's got rotational symmetry, right? So it's going to do that. I could take this whole thing and spin it around 180 degrees and it would overlap perfectly, okay? And so by knowing the values of a, h, and k, we can just tweak this thing, right? So what would we do then with this problem? What do you mean, well, what do you mean by simplify? Okay, so we're going to divide it out, right? We're going to divide it out. So what are our options dividing it out? Well, we can use long division. That's fine. Could we use synthetic division with this? We haven't done one like this, but could we?
Yes.
How's that work?
You solve x being an equal 3/4.
Okay. So we could find the 0 of the bottom, which would be negative 3/4, and that's a little bit awkward, but it still works, right? We could still then put the coefficients up here, 12 and 12, and we can't do it. If I bring the 12 down, what's negative 3/4 times 12? Negative 9. Plus 12 is positive 3 is our remainder. Okay. So then what's that tell us? What does this tell us down here? That this is equal to?
X plus 3. Right.
It's
being stretched by a factor of 3.
okay, but what is it when I want to write this? I've divided it out. What is that quotient equal to?
1.
What does the 12 represent? Right, this is the remainder, isn't it? In the box. And then this is going to be the constant. If there were another number, it'd be the coefficient of x, etc. Right? So this is going to look like 3 over 4x plus 3 plus 12, right? Does that make sense? Okay, so then how am I going to do that? How am I going to find h and k there? You know, I made that a little bit hard, didn't I? That's kind of...
It's being moved over what's being moved to the right.
Okay. Right. So if I've got, now what do we got to deal with this part right here, right? If I've got, this is a little bit harder than the ones in the book, but we can still do this. So if I've got 3 over 4x plus 3 plus 12, and I've got to write that in the form a times 1 over the quantity x minus h. Okay, so I need to get, I'm going to factor the 3 out, but I also have to have an x by itself there, right? So from the top, I can factor that 3 out front, and then I've got 1 on the top. What would I factor out of the bottom if I want to have an x by itself? I've got to factor a 4 out, which means I'm just dividing by 4, right? So if I pull a 4 out front, then I'm left with, if I divide each term on the bottom by 4, the first term is going to become x, what's this term gonna be?
0 over 4.
Yeah. Okay, does that make sense? Plus 12. So we end up then with A is 3/4, H is negative 3/4, and K is 12, right? Does that make sense? Okay. All right, so, that's, how many people have started that little segment?
I tried.
Raise your hand if you started it. I might just tweak, I see one thing, those are, I'd rather not have you have to deal with fractions. I might tweak that problem, tweak those so they end up being more like the book, where that would be something like a 3x plus 6 or something on the bottom. So they work out to not have to have fractions for H and K. I mean, you can still do it, but I might do that. As soon as we're done here, I'll fix those. How about, what would you do with a problem like, oops. How about something like that, where you got a fraction on the bottom? What would I just want to do one step here. What would you do if you had a fraction down there? To make that look simpler. Think about the things you can do to an expression so you're not changing the value, but you're just changing the form. Say it again. Multiply by 3 over 3. I can multiply by 1, right? I have to multiply the top by the same thing as the bottom. But if I multiply by 3 over 3, you see that I'm not changing the value, right? I mean, that's just multiplying by 1. But what's that give me? If I multiply top by 3 and bottom by 3, when I distribute through the 3 on the bottom, what do I get?
X plus 12.
Good. And on the top, I just get 3x minus 3. Much better, right? Does that make sense? Okay, now easier to divide, right? If now I can just use synthetic division, and we'd end up with, what's the 0 at the bottom? And then my coefficients on the top would just be 3 and negative 3, right? Drop the 3 down, negative 12 times 3 is negative 36, so I get negative 39 remainder, right? And then 3 is the constant. So this whole thing, I could just set that equal to negative 39 over x plus 12 plus 3. So I could pull the negative 39, I could pull out front and make that a then. If I want to write it in, oops, I keep doing that. If I want to write it in, oops, it's down here, never mind. I want to write it in that form, right? Then I just have to factor out whatever is in the numerator, and that becomes a. So I'd write that as negative 39 times 1 over x plus 12 plus 3. So what's a? Negative 39. H is negative 12. K is 3. Good. Okay. What else? Okay, so I'll tweak a couple of those real quick before you work on it. Let's look at this next page here, graphs. Okay, what about stuff like this then? What if we want to graph this function? What's been done to the parent function, the parent inverse function? What are the values of a, h, and k? So a is 3. What's that mean? Stretch vertically by a 3. Where is, it's not really a vertex, but where is the kind of the home point, right? The place where the asymptotes cross. Because normally, it's right there, right? That's kind of the value, that's the value of h and k. That's the part that we're gonna track. It's not even on the function, but remember, that's the place that it's easy to keep track of. That point right there, where the horizontal and vertical asymptotes intersect, right? And if you know where that point is, you can draw the horizontal and vertical asymptotes, and that makes the function really easy to sketch. So, where is that in this case? What are the values of h and k? 3, 2. Okay, so we should go over 3 and up 2, and that ought to be the place where the asymptotes cross. So that looks pretty good, right? In this case, asymptotes go where they're supposed to. Oops. Oh, man, my struggle. So there's one asymptote. There's one asymptote right there. There's one asymptote right there. So they cross where they're supposed to. Now let's pick a point that's another point that's recognizable. We should go over 1 and up 1. How far are we going up? Right? When we move to the right from HK, we should go up 1. How much are we going up? How much step and stretch? So that's it, isn't it? Everybody agree? See how that works? Okay. Let's try another one. Okay, this one's a little different. It's not quite as convenient. Right, this time it's not written in a form where we can recognize A, H, and K. So what do we have to do first? Yeah, we're going to have to divide it out, put it in that form, right? So what do we get? On the bottom, if we just use synthetic division, 0 of the bottom is -5. Coefficients of the numerator are 1 and 8. So bring down the 1, -5, and so I get 3. So what's that equal to then?
3 over x plus 5.
Okay, so 3 over x plus 5 plus 1. So what are the values of A, H, and K then?
1.
What's A going to be? 3. No, it's going to be 3, right? Because I'm going to pull that. If I factor out the 3, I would write that as 3 times 1 over x plus 5 plus 1. So there's A, right? What's H? Emily, what's H? -5, good, because it's x plus 5, so x minus -5. And what's K, Maisie?
1.
1. Okay, so that tells us then that the intersection of the asymptotes ought to be at -5, 1, and it's being stretched vertically by 3 and not reflected, right? So let's find that then. So -5, 1, right there, right? There's -5, 1, where the asymptotes meet. And then if I go over 1, I go up 3, so that's it. Right, everybody agree? Does that make sense? Questions on that? Okay,
Yeah, up 1, not down.
say it again.
Because that one is negative.
Oh, did I go, oh, it should be up 1, you're right. It's the wrong one, isn't it? It's back 5 and up 1 it should be, you're right. So that one probably, right? Back 5, up 1, and then I go over 1, and instead of going up 1, it stretches it to up 3. Okay? Good. Let's look at maybe, so now we have to do the opposite now. We're supposed to write this, based on the graph, we have to write the function. So based on the graph, what are the values of A, H, and K? Well, what H and K would be good ones to start with. What's H? 1, okay. What's K? All right, so if H is 1, K is -2, what's A gonna be? Okay, so when I go over 1 to the right from the home point, I should go up 1. I'm going down, so what does that mean? It's negative. And instead of going down 1, I'm going down how far? So A is what then? Negative 1/2. Yeah, good. So A is negative 1/2, and then this would just be negative 1/2 times the quantity 1 over x minus 1 minus 2, right? Okay, and then I had you do one also, and once again, this is a little harder than the book assignment, but I had you do one, I think, yeah, where you've got to write one. So you've got to do the same thing, only this time you have to write it as a rational function. So let's just take that last result we had. How would we take that result and write it in the form of a rational function instead of writing it in form of a transformation of an inverse function? Right. So we had f of x equals negative 3 times 1 over, what was it, x minus 1? Is that right? And then minus 2. So how would I do that? How would I do the algebra? Okay, I could distribute the 3. So I get negative 3 over x minus 1 minus 2. Now what would I do there? How do I add up? These are really fractions, aren't they? How do I add up fractions or subtract fractions? I have to get common denominators. Okay, so what's my common denominator going to be? Aha. Okay, so I'm going to have to, what do I have to do then? I already have a denominator of x minus 1 in the first term. What do I have to do to the second term? What would you do? So what am I doing to get that though, Joe? You're right. I'm multiplying top and bottom by x minus 1 to get that denominator, right? So what's that going to give me then? I'm going to end up with a common denominator on the bottom of x minus 1. I've got an x minus 1 there, and I've got an x minus 1 there. And in the numerator, I'm going to get negative 3 minus, and then what do I get when I distribute? Minus the quantity 2x minus 2, right? Do you see how I got that? I'm just distributing, I'm subtracting, and then I'm just distributing the 2. If I distribute the negative sign, that's just going to give me negative 3 minus 2x minus a negative is plus 2, all divided by x minus 1. And if I just collect like terms on the top, I get negative 2x minus 1 over x minus 1, right? Okay, so when you're doing this kind, it would definitely be easier to start off writing it in terms of a, h, and k, but then all you're going to do is just add things up, right? Add up the two terms, simplify it, okay? Get a common denominator, and put it in rational form. This is something we'll do a lot of this in calculus, this kind of thing, dealing with rational functions. Okay, so I just want to give you a little taste of that. I mean, we're not going to do a ton with it. Yes, ma'am.
The book wants us to state the domain and range using set notation.
Right, okay, so the domain and the range. Let's look at, and I didn't give you any of those on this assignment, did I? Or did I?
In the book assignment.
Yeah, I made some problems on here too. I don't think I've assigned them yet. Let's look at those. So let's just go back to something like previous page. How about, what if I had, yeah, like one of these.
3 and 4 is the domain.
Oh, okay, gotcha. There we go. There we go. Okay. domain and the range. All right, so what are the domain and the range gonna be here for this one? If I put this into, I'm gonna show you a shortcut on this. I was gonna show it to you tomorrow, but maybe I'll even show that to you today. How could we do this using, let's go back to this one, because we already did it. We turned this into, remember we had this, we multiplied top and bottom by 3, and we got 3x minus 3 over x plus 12. Does anybody have in their notes what we got for, we don't have to redo all this algebra. What did we get for an answer when we wrote that in the form a times 1 over x minus h plus k? Do we have that? Got something plus 3. Yeah.
Negative 39.
That was, okay, negative 39 times 1 over x plus 12 plus 3, like that. Okay, so then what's the domain and the range going to be? So if we know the coordinates of h and k, that tells us everything we need to know. How come?
Those are the minimum values for x and y.
Well, those are the places that defines that point where the asymptotes cross, right? So if I look at this parent graph right here, what's the domain and the range of that parent graph? What's the domain? Are there any x values that aren't defined?
0.
How come 0?
This is the asymptote.
Yeah, because there's a vertical asymptote there, right? That's the only x value that's not defined. Agreed? Okay, what about y values?
0.
0, because that's where the asymptote is, right? If the ant walks along this function forever to the right, he's gonna get to every positive x value. If he starts up here, close to 0, every positive x value, but he'll never get to 0, will he? Right? He'll get arbitrarily close to it, but he's never gonna get there. If he walks backwards along in the negative x direction forever, he's gonna approach 0 again, but this time from the bottom, right? If he walks increasingly close to x equals 0, he's going to climb infinitely high, but he's never going to get to x equals 0 because he can't, right? The mountain just keeps getting steeper and steeper. Never gets to the top, right? If he walks towards x equals 0 from the left, he's going to drop down forever. No limit to how far he goes, but he's never going to get to 0 because it just keeps getting too steep. Right? So if we know the coordinates of h and k, we're set. So what are the values of h and k here? Negative 12 and 3. So what's the domain? There's a couple ways you could write it. They want you to write it in set notation.
Yes.
Okay, so you could, I'm fine, and it'll accept if you just do this. You could say x is not equal to 12. That's fine for the domain.
Wouldn't that be negative 12?
Negative 12, you're right. Or if I write it kind of the long way using set notation, what's that look like? How do I say everything except negative 12 in terms of intervals? It said interval notation, right?
It's a interval, inequality, and set. We've got no clue. What set
Oh, you mean
is.
in the book, you mean?
Yes.
Oh, set notation. Set notation just means, remember, that's just it. Set notation is just, you just put it in brackets. That's all you're doing is you're putting it in brackets. And you're saying for x, x is whatever the inequality notation says. That's all they're saying.
How would you
I don't care if you do set notation, just ignore the set notation part.
Okay.
That's not a big deal.
So to write it as an inequality, would you have to say x is less than negative 12 and x is greater than?
Right, okay, so if we write it using interval notation, we'd say it this way. Right, there's one interval, x is gonna be less than negative 12, or x is greater than negative 12, right? Using inequalities, we'd say x is greater than negative 12 or,
Equal to, can't it?
Yeah, it's not equal to.
oh, not equal to, you're right, not equal to. X is greater than negative 12
Or X is
Or-
less than.
There we go. X is less than negative 12, and the symbol for or would be like that. Okay, if you want to use math notation instead of the word. Okay. But on Moodle, I think I just asked you for, remember Ruby, what I asked for on Moodle, wasn't it just, I think I just said write it in near pin.
On the domain range one?
Yeah.
Just, yeah, use the interval.
Interval notation, yeah. Okay, does that make sense? Right? And ignore the set notation, it's not a big deal, you don't need to do that. Just know how to do it, and you guys already know how to do interval notation and inequality stuff. Main thing is, I just want you to know, what's the domain and the range of one of these functions, right? The only values that are excluded are the x and y values corresponding to the asymptotes, right? And then I think I threw on one more. Let's see. I threw on. I guess I didn't. No word problems. I built one, but I don't think I put it on this time. I think I put it on the next one. Yeah. Oh no, there it is, right there. Okay, so how are you gonna do that? How are you gonna set up a problem like this? And when you're asking for these average cost, that's when you'll see, you'll as you do more math, you'll kind of see why that's when these functions pop up. But if we wanted to do something like this where he's got some upfront expense to buy software, to edit photos, and then paper costs $4.75 per sheet. So what's the total cost?
64.75.
But I mean, not for, no, I'm just saying, what's the cost function gonna be? And this is just gonna be a linear function, right? If I've got a certain incremental cost, that's the rate per sheet, and then this is like what you might call start value, right? So if we're just coming up with a cost function, what's cost as a function of x, where x is the number of photos? What's that gonna be? Kirk, what's that gonna be? X is the number of sheets. So it costs $4.75 per sheet.
So, 4.75.
Good, so that's saying, that's the cost for sheets, right? And then if there's an upfront cost of 60, plus 60, there you go, good. So that's M and that's B, right? Does that make sense? But so what happens then, if I want to come up with an average cost per photo, right, an average cost per sheet, what's the variable representing the number of sheets? X, okay. So that would be dividing both sides by X, and we'd call that like C bar, an average amount. Now this is kind of calculus. This is getting you ready for calculus a little bit. That's why I like this problem so much. This will make, the context will be clear in a couple of years, but what would this do mathematically if we divide by X? What does it look like on the right side then? If I split that into two terms, what am I gonna get?
4.75x over x.
Okay, so 4.75x over x, what happens to the x's?
Cancellation.
They cancel, right? So I've got a 4.75. What about the other term? 60 over x. So I could write that as 60 times 1 over x. Okay, that looks familiar, doesn't it? Right? So now we know what that graph looks like. That's just going to be an inverse function, right? That's stretched by 60 and picked up by 4.75, right? So if we wanted to be able to model this, that's pretty handy. Right, then we're gonna go over 1 and up 4.75, so that's gonna be there's the intersection of the asymptotes, right? And then it's just gonna look like a curve up here, but instead of going over 1 and up 1, I'm going over 1 and up 60, right? So it's stretched quite a bit, but it's just gonna look like an inverse function. Okay. What's that tell you about well, I guess I don't go over though, do I? That should just right be on the axis. Right, anybody see that? I kind of messed that part up. It's the H is 0 and K is 4.75. So this is actually the y-axis, right? What's that tell us about the average cost? As X increases, what happens to the average cost per item, per sheet of paper? It increases?
Oh, no.
Yeah, it gets smaller, doesn't it? Right? Because this is my average cost function, cost per sheet. That's what we're looking up here, average cost per photo, right? It goes down. Does that make sense? That it would? That's what we call an economy of scale in economics. If you do a lot more of these things, then that $60 becomes less significant in the overall cost, right? If I'm gonna do 1 million sheets, well, that $60 isn't such a big deal anymore, is it? Right? See what I'm saying? Then this is gonna approach, the cost per sheet's just gonna approach 4.75. Right, that 60 starts to get really minimal when you divide it over that many different sheets, right? Get the idea? Okay, does that get you going a little bit? All right. I'll tweak a couple problems there. You can reload them. Have at it. You can come up and ask questions if you'd like to also.